So our project called Automated Bottling, Capping, Labeling, Stamping Line, made by Madina Naumagambetova and Nargiz Azat. So in there, we designed and programmed a fully automated bottling line implemented in Codesys and visualized in Factory IO. The core problem we solved is how to move each bottle through the multiple processing stages while continuously checking quality and automatically rejecting defects. The goal is to have a modular, safe, and scalable control system that can be deployed both in simulation and real hardware. So for the system architecture, the line is organized into several logical stages. So the entry stage is for detecting new bottles and running a vision check. Then we have the filling stage is to fill bottles to the correct level, and capping stage to apply and verify the cap, labeling stage to apply and verify the label, and stamping reject stage is to apply final stamp and remove defective bottles. And then we have also executed successfully, so it's just exit stage to exit the bottles. Then each stage contains its own sensors and actuators, but overall the whole process is unified and implemented in one program. For the system architecture, we have the main PLC program in the PLC PRG, and also several like slots for the each stage, like entry slot, filling slot, and so on. And then we also have the two key flags is has bottle and is defect is to get if the bottle is there and if there is some defect. So each stage contains four states. It's idle, wait, process, and move out. Stages are running independently and connection goes through slot variables. Also, they're connected to functional blocks. Also, the visualization process goes from the getting global variables and connecting to of them to factory IO. So sensors and actuators. For the interzone, we have automod and e-stop. Automod is to running everything automatically, and e-stop is to stopping the whole process. And for the output, so we have conveyor motor that will run or stop the conveyor. And for the entry stage, we have bottle entry sensor, vision defect sensor, reject bin full sensor, operator bin replace egg. And for the outputs, we have reject diverter actuator. So for the entry stage, we have the bottle that will go there, and if there's some visual defect through the vision defect sensor, then it will be rejected by reject diverter actuator. And for the filling stage, we have a bottle at a fill pause sensor is just to get the if the bottle at the filling uh, position. And a level OK is to get if the filling executes successfully, and fill value is to fill the bottle with the liquid. And for the capping, we have bottle at cap position sensor, cap present sensor, and cap torque sensor. It's the same with filling, but also we have cap present sensor. That means to check if the caps is there. And also capper head motor is to is for capping process. And for the labeling, we have bottle at label position sensor, label present sensor, label applied sensor, and label aligned sensor. And for the actuators, we have label motor, label vacuum, and label applicator. And for the stamp, we have the same logic. So bottle at stamp position sensor and stamp applied sensor. And for the outputs, we have stamp motor and reject diverter actuator to reject the bottles that get defects for the whole process. And also a bottle exit sensor to exit the bottles that are not rejected and are completely fine. So if we go to the entry stage, before the entry stage we have the general moving position, but then we get to the entry stage and uh, they had uh, the idle, the wait, the process. So for the idle, we just wait until automate is enabled. So then entry stage go to the waiting, and in the waiting we get if there is a bottle and if the bottle enters the stage, then we have the has bottle is true and is defect is false, and the stage go to the process. And for the process, we have the function plug for uh, finding defects. And if there's some defect, then we get the reject diverter actuator true. So the defected buttons would be rejected. And if it's not, then we also have the entry stage goes again to the waiting and also has bottle goes to false. But uh, we got from the entry stage to the filling stage. And in the filling stage is the same. For the idle, we just wait until auto mode is enabled. For the waiting, we have has bottle and bottle at filling fill pulse sensor. Then if both of them true, that means that bottle at the filling stage and uh, filling stage go to the process, and for the process we go to the function block for the filling, and it starts filling if we have start filling as true, and also bottle at the filling position. And if it's not already in the process, so if is another bottle is not already in the process, then we start uh, fill value and is filling. And also we start executing the time, and if everything running successfully, so the bottle filled with the liquid at the time that we needed, then everything would be okay, and the bottle goes to the next stage. But if it's not, then bottle would get the long filling defect. The same is for the capping, but also we also need to get if there is a capping capture, and if the capping process also executed successfully, and if it is, then we go to the next stage, and if it's not, then we also had the cap defect, but the cap okay, it means that capping process executed successful and it will be false. And for the labeling stage is the same. Mostly we just have more processes is to like vacuum and putting applicator and so on and so on. And for the stepping stage, we also have rejection. So after the we got like after we got the defected bottles, we go to the rejection stage, and all the bottles that has defect would be rejected. And if a bottle is there and uh, it still has a bottle and also it's not defected, then it goes to the exit stage, and then all of this executed again. So to connect to a visualizer, we get all the sensors and actuators in the Modbus, so the Ethernet, and putting all of this here with the addresses. So each of them should have the address, and also each address should be connected with the address in the in the factory I/O at the same time. For example, if you have some sensor, for example, bottle entry sensor, it would be visual sensor, for example, then the sensor should be connected to the input 0. Since the address here is IX 0.0, and so on. And also, for all of this, uh, we needed to execute it in online, and also we needed to put symbolic configuration with all the global variables.
So here is our visualization. We used Factory.io to show our final visualization of our code. So in our product, we coded the conveyor line for filling, caping, labeling, and stapling the bottles. Uh, a minor flaw of our conveyor, we use boxes instead of bottles. And here I will go through all the stages. So first of all, we emit some bottles. For example, here it's randomly blue or green. Green boxes uh, means defected bottles. So in the first we checked for defects, and if everything is normal, bottle go through all the stages. So when a bottle is on the right position, uh, motors uh, turned on, and filling, caping, labeling, or stamping is going on. So this is how everything is going. Next thing that I wanted to show is our operator display. It is emergency stop, then a count of bottles that go through the conveyor, and how much um, can go next. For example, uh, for how much it is conveyor has ink or paper for labeling. So operator can reset it. I set it as default as 150, and also here is our uh, uh, count of bottles that go through. If we press emergency stop button, everything stops.